is section 3.6. So the last section you would have done was 3.4, right? That was multi-step inequalities. I am skipping over 3.5 because, again, I believe this book has it wrong or in the wrong order. We are moving on to 3.6. We'll come back to 3.5 in a little bit. 3.6 is what we call compound inequalities. Compound inequalities are two inequalities put together by and or. So we have two different kinds we're going to talk about today. The first type is an and inequality. An and inequality means that the solution set must make both inequalities true. So when we say and, it's kind of like saying it is sunny outside and it is 70, which means in order for that to be true, it has to be both sunny and 70, right? For that to be a true statement. Same thing here. It has to work with both inequalities. I was just dreaming. That's why. I was dreaming about outside. It'd be great. Or. For an or inequality, the solution sets must work for one inequality or the other. So if I use that same sentence I just said, and instead I change it to or instead of and, it is sunny or it is 70 outside. In order for it to be true, one of them has to be true, but not both, right? So that's the difference between these two. Now I want to kind of give you a general idea of what each one looks like. And the easier, the one that's going to make the most sense to start with is and. So we're going to work with that one first. An and inequality. When we have an and inequality, it can be written two ways. It can be written as two inequalities with the word and in between, or it can be written as one double inequality, which I'm going to show you examples of both of those in a second. When I say and, for example, let's say I have x is greater than 3 and x is less than or equal to 6. When I put that on a number line, at 3, because it is greater than 3, that is an open dot and it goes this direction. At 6, it is less than or equal to, so that would be a closed dot, and it's less than, it goes this direction. So you will notice for all and problems, the answers or the solution set is sandwiched in the middle. All right? So this is where all of your solutions fall, or right in the middle between the numbers. Okay? The interval notation for this example that I wrote, it starts at the open dot, which would be at a parenthesis, a 3, it goes to the number 6, and this one's got a closed dot on it, so it's a bracket. So you'll also notice an and inequality does not have infinity anywhere. It is sandwiched between two numbers. Okay? All right. So let's try an example. Example number 1. I'm going to ask that you solve graph and interval notation. And we're going to start off with using the word and in between them. So let's say I have 2x is greater than or equal to 10 and 3x plus 1 is less than or equal to 34. So we have two inequalities with an and in the middle. So we're going to solve both inequalities. First one, if I'm going to solve the first one, I just have to divide both sides by 2. Very good. I get x is greater than or equal to 5. Over here, if I'm going to solve this one, I'm going to subtract 1 from both sides. I get 3x is less than or equal to 33. Dividing both sides by 3, I get x is less than or equal to 11. With, of course, the word and in between. Does everybody agree so far? All right, on a number line then, at 5, will I have an open or closed dot? Very good. It's closed, and it's greater than, so it's going to go this direction. At 11, do I have an open or closed dot? Very good. And it is less than, so it's to the left. So you'll notice our solution set is sandwiched in between the two. Interval notation starts at the closed dot at 5. Goes to 11 with a closed dot or a bracket.
Oh, yeah, so closed dots are like you got it at the bracket?
Yes, closed dot is a bracket, open dot's a parenthesis. All right, any questions so far? All right, let me do an example showing you the other way an and problem can be set up, okay? All right, so here's example number 2. Example number 2, again, I'm going to ask that you solve graph and interval notation. And maybe we have something that looks like this. 3 is less than 4p minus 5, less than or equal to 15. So this is what they call it. Yep, I know. This is an and problem because where do you see the variable? It's sandwiched in the middle, isn't it? Okay, so this is an and problem. Now, whatever we do to the middle to get p by itself, you have to do to both ends. All right? So in order to get p by itself, the first thing we have to do is get rid of this minus 5. How do I do that? Plus 5. And again, whatever I do to the middle, I have to do to both ends. So 3 plus 5 is 8. I have less than, still have 4p, less than or equal to 20. Is p by itself yet? No, it's not, right? Yes. So if I divide the middle by 4, I have to divide everywhere by 4. Okay? So here, 8 divided by 4 is 2. Less than p, less than or equal to 5. Any questions so far? All right. So let's talk about, I know it's weird. It's new. I told you it's anything that's new. Let's start at, the first number we have is 2. Right? Now let's think about it. If we read from p, this says p is greater than 2. So we have an open dot, and it goes this way. At 5, it says p is less than or equal to 5. So we have a closed dot. Oh, this one is p is less than, so it goes this way. So again, your p is sandwiched between 2 and 5, just like it is here, just like it is here. Okay? I have an open dot, which would be a parenthesis at 2. Goes all the way to 5 with a bracket. So, a couple things I want to point out. All right? Again, p is sandwiched in the middle, right? All of our answers are sandwiched in the middle. Okay? You'll notice that my signs are both pointing in this direction. Looks kind of weird, but if you read from p, this says p is greater than 2, which it is, and this says p is less than or equal to 5, which it is, right? And it works for both. Any questions?
So is it just
What? Where it's sandwiched?
Yeah.
And is always sandwiched. Always, always, always.
Oh.
Okay?
So what's the first segment? Is also and.
Okay, so this is one way to do and the one where you write and in between is the other way to do and. Yeah, we said I'd talk about or. We'll get in there. Hold on. For an and problem, yes. Okay, all and problems are going to meet in the middle. They're sandwiching in between two endpoints. All right? Let's talk about or. An or problem. The only way to write an or problem is with the word or in between. Okay? So an or problem, let's say I have, I don't know, x is less than or equal to 7, or x is greater than 5. Nope, how about 15? Sorry, my bad, 15. So for an or problem, if you look on a number line, at 7, I have a closed dot, and this says x is less than. So it goes that way. At 15, I have an open dot, and it says x is greater than, so it goes this way. For an or problem, your arrows go in opposite directions. And went together, or goes opposite. Yes, Jackson?
Does it matter to write 15 first?
Yes. It's got to be in numerical order. Right? Yeah, so 7 is on this side on your number line, and 15 is on that side. Okay? All right. So let's talk about the interval notation for an or. If I was writing this one for this first interval, I start at my arrow, which was negative infinity, and I go to 7 with a closed dot or a bracket. This one starts at 15, which is a parenthesis for the open dot, 15, and this goes to positive infinity. The only thing we have to add to connect these two together is a U in between. So, it stands for union. You are putting a union or putting them together. That's what it means. Now, again, I want to remind you, when it was an and problem, it was sandwiched between two endpoints, no infinities, right? Or problem is sandwiched between two infinity signs. So you have a negative infinity on this side and positive infinity on that side. They go in opposite directions. All right? So let's try example number 3. Again, I'm going to ask you to solve graph and interval notation. And let's go with something light. 4D plus 5 is greater than or equal to 13. Or 70 plus 2 is less than negative 12. Negative 12. All right, so again, I have two separate inequalities, right? I have to solve them. The first one, if I'm going to solve this first one, I'm going to subtract 5 from both sides. I have 4D is greater than or equal to 8. Then what? Good. Divide both sides by 4, and we have D is greater than or equal to 2. Or, let's do this one. Over here, I have to move positive to the other side by subtracting it. So I have 7D is less than negative 14. Oh, sorry. 7D. Divide both sides by 7, and we get D is less than negative 2. All right, now I wrote it this way for a reason, to kind of cover that question that Jackson had. So this one says D is greater than or equal to 2. So if I have 2 right here, I have a closed dot at 2, and it's greater than, so it goes which way? To the right. Very good. This one says D is less than negative 2. Where is negative 2 on my number line? To the left. So I have negative 2 over here with an open dot, and it says it's less than, so it goes to the left. Interval notation. Starts at this arrow, which is negative infinity. Goes to negative 2. It's an open dot, so it gets a parenthesis. I'm going to put a U in the middle to connect our two inequalities together. I have a solid dot, so that's a bracket at 2, and it goes to positive infinity. No, I'm not going to mark you down. I'm just going to write it in and keep reminding you. Eventually, you won't forget it. Go ahead. All right. So questions so far. And is sandwiched in the middle, or goes in opposite directions. Okay? All right. So now let's get a little bit closer. Now that we know what the two things are, I want to talk about some of our homework. Okay? So here is example number 4. Probably 7. Yeah, we're on 4. It's not that big deal, you guys. You'll be fine. Here we go. So our next example is very, very similar to number 10 when you start your homework today. I'm going to ask you to write a compound inequality for the circumference of a volleyball must be between 14.5 and 15 inclusive. It's not a word problem. Nope. So we're writing a compound inequality. What word falls between my two numbers? And. So this is going to be an and inequality. All right? My numbers on the end are 14.5 and 15. My variable, let's use C for circumference, goes in the middle. Now remember I said that the signs always have to go the same direction, pointing towards the left. Because this says C is greater than 14.5, and this says C is less than 15. Now let's talk about the word inclusive. Inclusive means that it has to be included, which means it also equals on both of them. So if I were to graph this at 14.5, it says C is greater than or equal to 14.5. That is a closed dot, and C is greater, so it goes this way. At 15, we also have a closed dot, and C is less than, so it goes this way. So does that fit that it must be between 14.5 and 15? Absolutely. If I were to write interval notation for this, it'd be a bracket, 14.5 to 15 with a bracket. All right, any questions? Okay. Example number 5. It's going to be okay. They're not long examples. You're fine. This is going to be similar for 12 through 16. 10. All right, so again, I'm going to ask you to solve, graph, and of course, interval notation. Well, let's say I have 3 is less than 2 plus 4 plus x all over 3, less than or equal to, how about 7? So again, where's our variable? It's on the top in the middle, right? Which means it's sandwiched in the middle. So what kind of problem do we have? We have an and problem. So that should automatically tell you that when we graph it, it's going to be sandwiched between two numbers, right? And our interval is one interval between two numbers. All right, so now we have a fraction. How do I get rid of that 3 on the bottom? Yes. So I'm going to multiply 3 here, multiply 3 times this whole thing here, and 3 here. On this side, 3 times 3 is 9, less than. Here our 3's cancel. So I have 2 plus 4 plus x is less than or equal to 7 times 3, which is awesome. All right, now what can I do in the middle? Combine like terms. Good. 2 plus 4 is 6. All right. How do I move the 6? Good. And if I subtract 6 here, I have to subtract 6 everywhere. Exactly. So 9 minus 6 is 3. Less than. X less than or equal to 15. On my number line. At 3, do I have an open or closed dot? Good. At 15, do I have an open or closed dot? And where am I shading this? Where am I shading? This is X falls in between. Remington? It goes in the middle. Exactly. Goes in the middle. X is greater than 3, and X is less than or equal to 15. Interval notation, keep listening, is a parenthesis 3 to 15 with a bracket. Very good. All right. Example number 6. This is going to cover your 18 through 22. Then I'm going to ask you to solve graph and interval notation. So here, maybe we have 6b minus 1 is less than negative 7, or 2b plus 1 is greater than 5. So this time I got an or in the middle. What's that tell you about your graph? It's going to be or, which means what? Yes, they're going in opposite directions, right? All right, so first thing to solve this one, I have to add 1 to both sides. So I have 6b is less than negative 6. Dividing both sides by 6, I have b is less than negative 1. Or, let's do this one. Subtracting 1 from both sides, I have 2b is greater than 4. Divide both sides by 2, and b is greater than 2. On my number line, at negative 1, do I have an open or closed dot? Good, and it goes to the left. Excellent. At 2, do I have an open or closed dot? Open, good, and it goes to the awesome. You can see it goes in opposite directions. Interval notation. At the arrow means I'm starting at negative infinity. I'm going to negative 1. It's an open dot, so what do I put on here? Parenthesis, good. Then what am I going to put in the middle? Awesome. I have an open dot again, which is a parenthesis. 2 to infinity. All right, any questions so far? All right, yes. If it's all the way to the left, then it's a negative infinity. All the way to the right is a positive infinity. Okay? All right, so the next few problems, so 24 and 26, they give you interval notation. You have to graph it and write the inequality, compound inequality. Can we handle that? Maybe. Should I do an example, or are we good? Yes? All right, here, let's do this example. That's okay. Example, what am I on, 6? 7? Example 7. So 24 and 26. I'm going to ask you to write And graph. Inequality. And maybe you get something that looks like this. All right, so first of all, tell me what kind of compound inequality that is. And, very good. All right, so if I'm writing an and on my graph, and I think if I graph it first, I have a bracket here at -3, so what does that mean? Closed dot, very good. At 12, I have a parenthesis. What does that mean? Open, very good. And of course, we sandwich it in between, right? So that's what your graph would look like. Now writing our inequality. Oops, sorry. Get that out of the way. Go away. Yeah, let's not do that. All right. Okay, writing our inequality. We start at -3. We go out to 12, and we can put our variable in the middle. We're all good? This side, x is greater than, or it's a solid dot equal to. This side, x is less than 12. So the signs always go this way. Okay? Now, in the next couple, so that went to 26. 28 and 30, you're going to be given it in this form. You got to do those two. 32 and 34, you're going to get it in this form, and you got to do those two. Okay? The graph. So no matter which of the three, you can do the other two, right? All right, good deal. I think we are good. All right, so your homework today is on page 204, 205, 10 to 36 even. Yes, it's posted in Google Classroom, or you can use your book. All right? Oh, I can probably understand. Yeah, sign out for me, though.